Just want to go over the search algorithms. So first we'll just go over sequential sort, and that's sequential search, and that's really pretty straightforward. All it is just like, you know, how you would normally search for something. Like say you've got an array of literally anything, and then okay, let's say we're searching for the number 4, right? I would just start here. Okay, this isn't 4, move on. This isn't 4, move on. This isn't 4, move on. Okay, we found our 4. That's it. The problem is this is kind of inefficient because you have to go through the whole array, pretty much the whole array, before you're sure that you can find the element that you're looking for. But it's really the only way to search for something in an unsorted array, because you don't know, like if it's not sorted, you have no idea where anything could be. But when you have a sorted array, then you can use the binary search. And this cuts down the amount of searches checks that you have to run by a whole lot. So let's say we had, it has to be a sorted array. What am I doing? Yeah, so if we have a sorted array, okay, so we have a sorted array of elements or numbers or whatever, and what we do is we find the minimum. We keep track of the minimum index, which is just 0 right now, the maximum index, which is just the length minus 1 right now, and then we keep track of the middle. So the middle in this case would be 9. And then, you know, if you had an even number, just like the code, you just still do the length divided by 2. Integer division will give you either one of the left to the right of the middle. So, but right now our middle pointer points to 9. And what we have here is, okay, what we do is we compare the element that we're looking for to these indexes. So we have our min, mid, and max. So let's say we're looking for 21. So we see that 21 is greater than the middle and less than the max. Okay, that's good. If it was greater than the max or less than the minimum, then we know that it's definitely not going to be in our list or array. So we see that it's greater than the middle and less than the max. And really what that means is, since we have a sorted array, we know for sure that 21 has to be somewhere in here if it's in the array at all. So we've just cut down our size by half. We don't have to look at any of these numbers. So now our array is just limited, the part that we're looking through is limited to 9, 11, 21, 33, and 92. So our old middle turns into our new minimum in this case. And our old maximum is still our old maximum. Now we have a new middle, right? We have to calculate that. And that middle value happens to be, so our middle value is over here. We don't know that it's 21 yet. Okay, now we have found 21 because we checked that it is equal to the middle. Okay, great, that's good. So we found our thing. But say we had been looking for 33. So 33 was still greater than the middle value and less than the max, so this part still applies. So now our new middle is 21. Okay, now we compare 33 to the value at the middle, and we see that, okay, it's greater than the middle, and it's less than the max, which means it still could be in our array. And then now we've just cut down our size by that much, and now all that we're looking at is 21, 33, and 92. So our min, mid, and max. And then, okay, we see that 33 is equal to our middle. Okay, we found the value. So we know that it's at this index, middle. So really what binary search does is you're basically cutting down the part that you're looking for by comparing the number that you're looking for or the value that you're looking for to the middle index, the maximum index, and the minimum index. And when the element that you're looking for is at the middle index, then you've found it. So we're just waiting, we keep cutting down the size until our middle index happens to be our element, or it's just not possible for the element to be in the array. So let's do another example. Let's say we're looking for 7. Okay, so our minimum index is equal to 0. Our maximum index would be, just number these here. Maximum index equals 8. Middle index equals max minus min over 2, which is equal to 4. So you can kind of see how this would translate to code here. Okay, now we're looking for 7. Okay, so let's just make this array. So let's compare 7 and array.0. Okay, so array.0 is 1. Okay, 7's greater than that. Okay, now let's compare it to array.mid. Okay, 7 is less than 9. So we know that it's between our minimum and our middle value. So we can just get rid of that part. And now in our new part of the array, we're looking from here. So we're looking at 1, 2, 5, 7, and 9. So what's our new minimum? Okay, so in this case, since 7 was less than the middle, our minimum actually stays the same, unlike before when we changed the minimum. So our minimum is still index 0, but now our maximum is equal to the old middle because we just cut it down to the middle. So our maximum is going to be equal to 4. That's the index. And now our new middle is equal to the max minus min over 2 always. So that would be equal to 2. So it's pointing to 5 right here. Okay, now once again, we compare 7 to each value. 7 is greater than the minimum, or the array minimum. So it's greater than that. Okay, it's also greater than the middle value, but it is less than the maximum value. So that means it's between the middle and the max. So now we're looking at 5, 7, and 9. Okay, now our minimum is our old middle because we moved to the greater half of the array. And our maximum is equal to the same one that we just had before because 7 was less than the value at our maximum. And now our middle value is equal to max minus min over 2, which is 3. And now, okay, we check 7 with the minimum value. It's greater than that. And we check 7 in comparison to the middle value. Okay, it's finally equal to the middle value. And we already know that the index of the middle part is 3, so we can just return that our value that we're looking for is at index mid or 3. So we just return that value. So that's how you do binary search. You're basically just cutting down the sample size that you're looking through until you're basically down to like 3 numbers, and then your element that you're looking for is the middle one, or until your element is out of range and then you know that it's definitely not in the array at all.